Yeah, so I have come across this program called Promise. Uh, you've both heard of it.
No.
So this Promise is basically a math camp that is going to be held at IISc in the summer. So basically, there is like a similar camp that's happening in the US, and yeah, they are inspired by it, and they are conducting a math camp this year in IISc. So they have put out a kind of a question paper. So anyone, it's specifically for kids, I think aged like 15 to 17, basically who are in class 10, 11, 12. So they have put out a question paper, and students who are interested can submit their answers. So I thought I will share, can at least work on some of the questions. Right. So this is the problem set. There are 8 problems. Yeah, so basically it is, I mean, it's not like the objective kind of question, it's like some thinking questions. They are saying it just requires high school math. So the topics are, yeah, I guess like maybe you can include like 11th, 12th class also. So yeah, I mean, I'll just like leave it on for you to read. So yeah, maybe we can work on the first question. I also have not gone through it. Uh, on it, or can we discuss the answers?
So I only have examples. I don't have any generic stuff yet, generalized stuff yet.
Okay. Yeah, maybe you can share your specific answer. So, Shubhangi, what was your answer?
I got answers for 5 elements, even 3 elements, 7 elements. But as Gauri said, even I cannot generalize it. But what I have observed, I can annotate. 15 minus 8, 7 minus 1, 6 minus. Then all positive. So instead of negative, I got the series become positive. So 1, 2, 3, 4, 5. So this were with 5 elements. So now what I observed means I tried instead of 15, if I try with 16 and this minus 9, again same thing will happen. 1, 2, 3, 4, 5. So again with 5 elements. Well, the sign alternate. And this is, I was on this. I got something for 7 also. Then 3 elements, 4 elements. This is, I was just exploring this, like instead of 1 now, if I add 2, 16 plus 2 is 18, 9 plus 2 is 11. So still I will get with 5 elements in this case also. No, I think I got it for
Yeah, I have a hypothesis. Again, yeah, I don't know. If whatever is the starting number, the next negative number should be around half its magnitude.
If it's half or less than half, it will end with 3. The alternating will end at 3. So for example, 20 minus 10 or 20 minus 9 or 20 minus 8, whatever, so then you'll start getting all positive. So it has to be, the magnitude has to be more than half.
Yeah, just above half is correct.
so you get 1, 2, 3, 3 elements positive. I mean alternating.
It, it, yeah, it should be around half and greater. It can't be like n. So if we take n, it can't. If we take the next number can't be magnitude n minus 1. That will also end up quickly actually.
No, what if this 20 and minus 10? So instead of 10, if I take 11 now, so what
Yeah,
will happen?
that should, it seems to me that
Again,
it should
4 only. 9 minus 2, and then everything is positive after that. 7 plus 5 it will be.
11 and minus 6. Can you try that once?
1, 2, 3, 4, 5, 6. So you will get 6 elements here. What did you say, Shravan? Not clear.
11 and minus 6.
1, 2, 3, 4, 5. So 6 is bigger than half of 11, right?
Huh.
So the second number should be either half or bigger than half. Then you will get
Gauri Akka,
Huh.
20 and 11 we will get longer sequence, no?
No, it goes 20 minus 11, 9 minus 2,
Huh.
7,
Huh.
and then 7 minus 2 is 5 only, right? After that, everything is positive.
sorry,
No, you
sorry,
should
sorry.
do first number plus second number, no?
Yeah, so minus 2 plus 7 is plus 5.
Okay,
So
okay, okay.
after that, it's all positive.
Oh, okay.
So 11 and minus 7, it gives you 6 alternating things.
Mhm.
11 and minus 7.
Hmm.
So this is 1, 2, 3, 4, 5, 6. For 11 and minus 7, 6.
I don't think it will go more than this. It won't go more than this for 11.
I'm wondering if it is somehow linked to the Euclidean GCD algorithm.
Perfect. Yes, Shravan, yes, it is.
So which pair of numbers will give the longest number of steps to find the GCD?
So I don't see the GCD algorithm angle. But it looks to me like this is 2 Fibonacci series added up.
2?
So Fibonacci series added up.
Oh,
So if I start with A and B, where B is actually negative B when we write it here, but considering it as A and B, then the third element will be A minus B, fourth element will be A minus 2B, fifth element will be 2A minus 3B.
yeah, no, it is the Fibonacci pattern because the whatever current number, it is the sum of two previous numbers.
Correct. So looking at it this way, if we want a series that has this alternating up to a certain level, let's say up to 1, 2, 3, 4, 5, 6, 7 elements, if we want up to 7 elements, if we want it to be alternating, then 5A minus 8B must be positive, but 3A minus 5B must be negative. It has to meet this criteria. So I'm trying to see if trying to see if I can do something with that.
Nice. So, Gauri and Shravan, can you see that both of your observations are actually related? That is, Shravan said it has something to do with Euclidean algorithm. That is actually related to this question, and it's related to Gauri what you said also.
Oh,
So if we observe the part till where it is alternating, we can see that the magnitudes are decreasing continuously, and the moment it starts increasing, that is where the alternation stops.
Yes.
Yeah. So yeah, what it seems to me is in GCD, every time we take we subtract and we keep recursing that, right? So every time if the subtraction, the new value that we are getting, that should be continuously decreasing.
Okay, so basically, Shravan was saying you have the GCD algorithm, and in GCD algorithm, if you take two numbers like say 8 and 6, you will first take the difference of 8 and 6, so that will be 2. And then you will try to take the difference between 6 and 2.
Yeah.
So instead of taking a difference, it is the equivalent of adding 8 minus of that number. So instead of taking 8 and subtracting 6, it's the equivalent of adding minus 6. That's what we are doing here.
Hmm.
Uh,
So I'm seeing a parallel between what
Yes,
kind
correct.
of numbers, what kind of numbers will yield the longer GCDs and what might quickly uh, change to alternating pattern. Yeah, say for example, if we do GCD of 110 in this manner, right, using Euclidean's GCD. So the first step would be, okay, we'll write GCD of 110. So the next step would be GCD of 10 comma 100 minus 10, which is 90. 10 comma 90.
Hmm.
And the step after that would be again 10 comma 90
80.
minus 10. Yeah, 80.
Yeah.
So
80 and so on.
if we see the 10 is continuing, right? So the 10 is
Yeah.
persisting to the next step. So if
Hmm.
there are such steps, that will be the place where it alternates if you write this sequence. And if there is a GCD of two numbers where every time the new minimum is a new number, I think then it persists till as long as possible.
Hmm.
We can take some examples and write both the GCD steps and also the sequence. I think then we can see the parallels between these two things. Yeah, but how to characterize? Yeah, that's a very tricky question, I think. Yeah.
Okay, so if you give me any number, I will give you the negative number so that the sequence is correct.
Sequence is maximum, huh? Okay. Yeah, that's what I'm trying to figure out.
The alternative sequence is maximum, right?
Did anyone find a sequence of this type that starts with 5 elements? That is done?
Yes.
Okay.
That's point one.
Yeah, I just found one. 8 minus 5, 3 minus 2, 1 minus 1, and so on. Is that
Nice.
correct?
Yeah, your sequence is 8 minus 5, 3 minus 2, right?
Minus 2, 1, then minus 1, and so on. Yeah.
Correct. So that is basically having a sequence of length 6.
6 elements. Okay. Okay.
Correct. So yeah, I think Shankar's answer should be a clue for all of us.
I mean, I've not done it yet, but one way I'm thinking is to create this pattern in the opposite direction. Like start with, say, for example, -1, and then go to the left. To create that -1, what are the two numbers that will be required? Any two numbers, and then go from there. Bigger numbers, maybe.
Oh.
On the left hand side. I just reached another sequence, another 5 element sequence. But after that, it's becoming again.
Yeah, what is your sequence?
It starts with 11.
Okay.
-6.
Uh,
5. -1.
right.
4 and 3.
So this is of length 5, right?
5 only, yes. After that, it is
So,
changing.
11 with -7, it gives you 6.
11 with, sorry, -7.
Yeah.
Will
We
give me
had
6.
worked it out
Okay,
just
okay,
earlier.
okay. 11 minus 7. 4.
This will be length 6, as Ashwin said. And Mega, yours would be length 5.
Yes, mine is length 5. And Ashwin's is length 6. Yes.
Okay, maybe I can combine your sequence with mine and try to figure out something.
Yeah. So I got my sequence by doing the same trick that I told that I'm.
My sequence is 8 minus 5, 3 minus 2, 1 minus 1, and then 0.
3 minus 2, 1
Minus 1,
minus 1 and
0.
0. Yeah, yours is also 6.
Yeah. Not even 5. Yeah.
It has
5.
to be, it should not be one less, it should be I'm just talking about the magnitude
Hmm.
number. I'm just like making a wild, no? I'm not even tested it yet till now. But the magnitude of the negative number be greater than half of the positive number. But it should not be like less than 1. Otherwise, it will be just 4. So I'm just thinking.
Correct. I think Shravan also had got it earlier. Yeah, basically we have figured out that the negative number has to be more than half of the starting number.
Huh. But it cannot be very high, right? Just
But
maybe
it is
one
not
or
always working. Yeah, but that is one case here, right? But it in that situation also.
basically the difference. I feel the difference should be closer to the again the bigger than the half of the second number, right?
Yeah.
For example, 11 minus 7 and then 4. So 4 is bigger than half of 7. So that way you should choose. Every time this following number should be bigger than the half of that.
In my case, it is not always working bigger than half. So it is a good conjuncture because I was also thinking in the same lines. But for example, I tried 12 and minus 9. It's not working. So I tried with 12 and minus 10. It is not working either. 12 and minus 8 is also not working. So yeah, but 12 and minus, sorry, I tried something else. Wait. Okay.
That's what I said, that it has to be 1 or maximum 2 bigger than the half. So 12 minus 7 will work.
So 12 minus 7 is giving you 5.
3 minus 2.
Sequence of 5.
Yeah, it is giving me sequence of 5. 12 and 7 is working. Minus
Sequence
7.
of 7.
It's not giving me a sequence of 7. It's giving me
How 12 minus 7, then 5, then minus 2,
then 3.
then 3,
Minus 2
then
is 1.
No, sorry.
Giving me a sequence of 5.
Yes. Yeah, I made a mistake. Sorry.
Okay. So now I am also able to make a sequence of 10 alternating.
Wow.
So 55 and minus 30.
33. What?
55 and minus 34.
Beautiful. 55 and 34 probably I think are coming in the Fibonacci series, right?
Yes.
What series?
Smart.
Oh,
Smart
okay,
enough.
okay.
Ashwin, is that the way you were going also?
Yes.
Yeah.
Okay.
Then this has got something to do with Fibonacci, man. Seriously.
So does that mean that 89 and 55 will give bigger number? Bigger number of elements?
Yes, I think so.
89 and minus 55 maybe you can start with as per the
Yeah,
rule.
yeah, that'll. You hit it, Gauri.
So once Shravan and Ashwin gave away this GCD connection, so I was trying to do it with the picture, where the squares. So if you have X and Y, and you're trying to find the GCD, so the
Okay.
algorithm boils down to so create a square of X.
X by X, right?
X by X.
Huh.
How many ever you can. Then in the remaining, you create. So this is X minus, Y minus 2X that is remaining, right? So you create a square of that. And then in this remaining place, you create squares again. This is what that algorithm boils down to if you do it visually.
So y minus 2x square.
That
upper square you are talking about.
So don't worry about the area, I would say. But look at the algorithm where basically you're doing y minus x, then again since
this is y minus 2x, and then
so this is essentially the same GCD algorithm, right? Euclidean algorithm. So you do y minus x. Y minus x is still greater, so you subtract x again. Now
this y
x
minus
is
2x
greater,
is smaller than x.
Smaller than x. So now you subtract that. That's basically what's happening here. So now we want to fill up this rectangle for this problem. We need to fill up this rectangle with as many different size squares as possible.
Right. Huh?
So then I just,
because if the size of the square is the same, then it becomes 0.
Then it becomes 0.
The result, na?
Then
what,
it becomes
what becomes 0?
The number.
Result will not be 0. See, the square with the smallest size, that will be the GCD of the two numbers x and y.
Correct.
Yes.
But so is that when it becomes 0? I don't know. I made a jump. And
so the thing is that the algebra thing is actually confusing. Maybe you can take two numbers and then explain. That would be great.
So if we take 8 and 5. Oh, that's why you were saying that. Okay, now I understand. So we have 8 and 5 here, right? So 5 by 5 we create. So there is 3 left over here. So we create a 3 by 3. So, oh, this is badly drawn. Then we create a 3 by 3. Okay, imagine that this is the 3 by 3. Then we create a 2 by 2, and then 1 1. Right?
1 by 1. Correct.
Is
1
that
will
right?
be the GCD.
GCD will be 1.
GCD will be 1. But the thing is, we have not repeated any of this. All are different sizes. So the way to maximize different size squares is what we are looking for. Right?
Yes.
And if you remember, you would have seen this. You would have seen this Fibonacci related diagram in a lot of places that this thing will come and you will see
Spiral.
one little square. Fibonacci spiral. There'll be one big square and then one smaller square and it goes in, right? That's essentially the same thing, arranged a little differently. But here the speciality is all are different size squares. All the squares are different size, right? It goes to the next lower. So this essentially gives the GCD between two consecutive Fibonacci numbers. So this will be, say, 5 is what? 1 1 2 3 5. Fifth one, F5 F6. So if you construct this, that is exactly the same as this diagram over here, but rearranged a bit. That's all. But the essence is that we have squares all of different sizes.
Yeah, but to make that connection was awesome.
It was thrilling.
Yeah, I think now we are in a position to answer both part A and part B. Yeah, so I will just show you the second question. We have seen the second question before.
Yeah, from Alex Bellows' Think Twice.
Yeah.
Nice story that's built around it.
That was a centipede or something, right?
No context was given. It was just elastic rubber band something.
Maybe an ant moving along the rubber band.
Wow.
And
though no kind of intuition says that will ever catch the hair, but I'm sure the answer is otherwise. But Okay.
Can I quickly, in 2 minutes, share something which was on my mind to discuss, and we can think
Yeah.
about it and come to next?
Yeah.
Yeah, sure.
Um, so there are these puzzles on the market called calendar puzzles. So it'll be like
Okay.
this. It will have some bits and pieces, and you can arrange it supposedly to make all dates. So for example, here it is showing November 29th, Friday.
Huh.
So these same,
Yes.
Can you enlarge the first?
and with the
Wow.
same pieces, it's supposed to work for all dates, right? But
Right.
clearly here, this 28th Saturday will not work. Can you see that?
Can you show the pieces? So,
Yeah, pieces.
Yeah.
Pieces, right?
These are the pieces. They're like multiple triangles joined together.
go back to the previous picture.
Why do you think these two won't work, 28 and Saturday?
Because there will not be a single triangle.
There's no.
Yeah, all the pieces are made by triangles joined edgewise, right? Oh, I can't.
Right.
All the pieces are created by triangles joined edgewise. And if you look at 28th Saturday, it leaves Sunday with no shared edge.
Yeah.
So obviously that cannot be done. So like I was trying to like analyze.
Yeah. Similarly, there will be some other example also, right? Similarly, for example,
20, this thing, the corner one, this corner. Okay, 20 and 30 anyway, that we
They're
don't
connected
want.
with only vertices and not edges. Yeah, makes sense.
20 and Tuesday, 22 and Tuesday.
Yeah, 22 on Tuesday will also have the same problem. But we don't know if there are any other problems. And how do you come up with something like this? And how can you be sure that, well, most dates, if not all dates, you know that most dates are going to be covered by those pieces. See, it's not just about it's not just about the board, right? Like these pieces, these specific pieces in different arrangements should be able to cover all possible day, date, month combinations.
Yes.
How to even think about this? So there are multiple versions of this. This is the triangle, obviously triangular grid version. There is a square grid version. There's also a hexagonal grid version. I've seen the square grid version before, few years before I'd seen the square grid version. These two I've seen only now. But yeah, I don't know how to think about this and if we can make some progress in.
So, yeah, basically, this is like a very impressive puzzle. But sorry to answer your question, this is not as crazy as you think. For example, you see that yellow hexagon, right? So that is having a hole.
Yes.
So just by rotating that hexagon, you can get that hole in like 5 other places also.
Correct.
So it's effectively like you are able to get that one independent hole.
Okay, right. Yes.
Right. So imagine that the next to that yellow hexagon, there are like two green trapeziums, right?
Yes.
Yeah.
If I just place it upside down, I can basically shift that hole to the other triangle. So it's kind of like the holes are kind of independent. That's my point.
Oh, is it?
Now, if I keep that trapezium upside down, I'll get a hole in a different place.
Okay.
So basically, now I am able to get like another. So my point is, if all the three holes are independent, that means everything, every possible combination of holes.
So you mean to say that these will be used as a like this only, means two green pieces will be together, not necessary, right?
Not necessary.
Yeah, what I think he's trying to say is it's not impossible to get all the.
So basically, you can just see, you can effectively get from one whole configuration to another whole configuration.
yes.
But only the physical version of this is available, right, Gauri? Not no.
So incidentally, there is a on Mathigan, there is a puzzle which is similar to this. Let me try to share. So this is essentially the same, right? It's saying spin all the spinners, place a black square on each number. So whatever these spinners give, so place a black square on each of those numbers.
Place a black
and
square on each number.
Then fill the
Yes.
square with the other shapes. This is essentially what we're doing, but we have only 3 openings because of day, month,
Fill the square with the other
date.
shapes.
In all the spinners, place a black square on each number.
Flip on the
Okay,
shapes and
even.
Yeah, it's essentially the same thing. So we can try with this.
So this is like I
So
think
what is the name of this puzzle, Gauri?
In Mathigon, it is given as Genius Square and Genius Star.
Genius square and genius star.
This is Genius Star.
Okay.
This has those triangles. So yeah, maybe we can play around.